Alright, so we'll go ahead here and we'll try our second problem of today. So this one is similar to the last problem, except two different things here. First of all, this time it gives us two different x-intercepts. And also, instead of having a function that has 4 terms, this one has 1, 2, 3, 4, 5 terms. Okay, now, because I've given you two x-intercepts, this time it's probably going to make sense that instead of doing synthetic division only once, we might have to do it twice. Now let's first decide what two factors did I give you for this function. Well, if it says that x equals plus or minus 2 are x-intercepts of the function, I should also note other words for x-intercepts might be roots or zeros. Either one of these words are used in place of x-intercepts from time to time. So if x equals positive 2 and negative 2 are roots, zeros, or x-intercepts, that means x minus 2 and x plus 2 are both factors of this function. So if we want to factor this, we could use either one of these factors first with synthetic division. I'll go ahead and use x minus 2 first. So let's see what happens if I take this function and I divide it by x minus 2. So what that means, I'm going to keep track of it here, x minus 2. What that means is I'm going to put a positive 2 in the box here. And if it really is a factor of this function, then when I do this synthetic division, I should get a remainder of 0. So let's try it. I'm going to drop the 2 down. 2 times 2 is 4. Add these together, I get negative 6. Add these two together, I get negative 12. Sorry, multiply these, get negative 12. This will be negative 21, negative 42. Subtract, I get negative 2. And then when I'm done here, I get negative 4, which, as I expected, gives me a remainder of 0. Now, an important thing on a problem like this is not to lose track of your work. So what I've figured out so far is x minus 2 times 2x. It's not going to be squared, actually. It'll be, in this case, it started out as a 4, so it will now be a cube. 2x cubed minus 6x squared is 21x minus 2. If I multiplied all this stuff together, I should get this original function. Now, as you notice here, this second function, or this second polynomial here, this could not be factored by grouping. The ratios here and here are not the same, so we're kind of stuck here, except I gave us enough information to keep going. What this means is we already divided by x minus 2. We don't need to mess with this anymore. But if x plus 2 is also a factor of this function, that means that we could divide this remaining polynomial by x plus 2, and we should also get a remainder of 0. So let's try it. Now you got to make sure you don't forget about this first x minus 2, but I'm going to divide this polynomial right here by x plus 2. So this time, instead of having a positive 2 in the box, I'll put a negative 2 in the box. 2, negative 6, negative 21, and negative 22. And again, if it's really a factor of this function, I should get a remainder of 0. So let's try. Drop the 2 down. This becomes a negative 4. Add them together, I get a negative 10. Multiply, I get 20. Add, I get negative 1. And multiply, and I get a 2. And just as I expected, I get a remainder of 0. Now, don't lose track of what we've already worked with. So far, we've already figured out x minus 2 is a factor of this function. Now we've figured out that x plus 2 is a factor of this function. And when we're done, we see this quadratic 2x squared minus 10x minus 1 is also a factor of this function. Now, unlike the last one, what we've got here is we've got a quadratic that cannot be factored any further, because please note there are no factors of negative 2 that add up to negative 10. So if you're trying to find factors of this, if you're trying to solve this for its x-intercept, you have two options. You could either use completing the square, or you could use the quadratic formula. And I am going to go over here and make a note right now. The multiplicity of this function is 4. Okay, it started out as 4 at the beginning, and when we're done, we have 1 plus 1 plus 2, and this is a positive function, so this is even and positive, so we know the end behavior is going to be up, up. We just need to figure out what all the x-intercepts are. In this case, we already know we're going to have 2 and negative 2, but we need to solve this last term here its x-intercepts. Now, I'm going to go ahead and use the quadratic formula here because that looks like it's going to be hard to complete the square because it does not have a leading coefficient of 1. So if I plug into the quadratic formula here, what I have is x equals negative b, which would be 10 plus or minus the square root of b squared, so 100 minus 4 times 2 times negative 1, all divided by 2a, which would be 4. So let's do some simplifying here. This becomes 10 plus or minus the square root of 100 plus 8, so that's 108 divided by 4. Okay, now you might not know this off the top of your head, but 108 is divisible by 36, so this becomes 10 plus or minus 6 root 3 all over 4, which is, if you can divide all these by 2, this would be 5 plus or minus 3 root 3 over 4. Okay, so our other x-intercepts here are 5 plus 3 root 3. And I'm sorry, this shouldn't be over 4, but this should be over 2 right here. So over 2 and 5 minus 3 root 3 over 2. And remember, from last week, both of these are going to have a multiplicity of 1 because this was squared and we got 2 x-intercepts from it, so each one has a multiplicity of 1. Now what we're going to need to do is we're going to need to put these in order from least to greatest on our number line. So we're going to need to make some estimates here on 5 plus 3 root 3 and 5 minus 3 root 3. Okay? 3 root 3 is the same thing as the square root of 9 times the square root of 3, which would become the square root of 27. So if I took 5 and I added the square root of 27, which is about 5, okay, 5 plus 5 is about 10 divided by 2 is about 5. So I can make an estimate here that this is approximately 5 point something. Okay, and if I took 5 and I subtracted something that's a little bit bigger than 5, I'd be barely negative, and divide that by 2, I'd also be barely negative. So this is like negative 0 point something. So if I'm putting all this in order, the first number that I'm going to have is negative 2. Then I'll have a positive, or I'm sorry, then I'll have 5 minus 3 root 3 over 2. Then I'll have positive 2, and then I'll have a 5 plus 3 root 3 over 2. Both of these, or sorry, all of these have a multiplicity of 1, and my end behavior is up, and I'm going to go straight through all of these because they all have a multiplicity of 1. We have to make some estimates here to figure out how we're going to line these up. But as we see, this is very similar to what we were doing last week on some of our problems, except we have to use synthetic division twice in order to factor this